Welcome to solverfy.
This is the answer to Chapter 27, problem number 38 from the Smith Organic Chemistry textbook. And we're asked to draw the products of two Diels-Alder cycloadditions and to make sure to note the stereochemistry at each applicable position. And so remember, the Diels-Alder is a 4+2 cycloaddition, and it's always superficial, and it's always thermal. And so it's going to proceed exactly the same way as all of the reactions that we've looked at in this chapter. So it's a paracyclic reaction. So the electrons will flow in a circle in a single step. So like that. And again, it's always good to just start by drawing the way that these electrons are going to move. It's going to make it much easier to draw the products. And so in this case, we're forming a new 6-membered ring fused to the 5-membered ring that we started with. So there is our new 6-membered ring. Our double bond is there. And then, as I said, fused to our starting 5-membered ring. So the carbonyls didn't participate. They're not affected. So they're still there. And now we do need to account for the stereochemistry around this ring. And as we said, this is a superficial cycloaddition. And so what we're going to see is both of these hydrogens there'll be cis for A. So for B, it's exactly the same reaction, but the starting material, the starting diene, one of the double bonds has cis geometry around it. It's the Z double bond rather than both of them being E double bonds. And so again, oops, and it looks like I have omitted a double bond in a starting material here. So let me fix that. There we go. So again, we can start by drawing electron movement. So new bond, this double bond moves over, and those electrons go to form a new bond as well. And so we get a product that is essentially exactly the same. The only difference is going to be in the stereochemistry at one position. And so there's that. We will draw our fused 5-membered ring there. Again, the carbonyls are unaffected. They did not participate. And there's the double bond. And so, again, this is a superficial reaction always. And so there are our hydrogens cis to one another and on wedges. And then this time, the difference between B and A here is that one of these methyl groups will be cis to the hydrogens, and the other will be trans. So one dashed, one wedged. And actually what we'll get is a mixture of the two. So we will get the other enantiomer as well. Enantiomer. So the other enantiomer, of course, being this bond that I'm arrowing in red could be wedged, and this bond that I'm arrowing in red now could be dashed. And so that's the products for B. This problem pretty nicely illustrates the effect of the double bond geometry in the diene on the product of a Diels-Alder reaction. And that is the answer, again, to Chapter 27, problem number 38.